what I need to tell you is that the empirical rule is fine and good if you have a nice number of standard deviations away. However, that won't always happen. You won't always be wanting to go between values that are 1 standard deviation away or 2 standard deviations away. And so if you're not a nice whole number standard deviations away, the empirical rule really is of no use. So we have to have another mechanism to do this, and the mechanism we will do is the normal table, using the normal table. Yes. All right, so let's look up our normal table. We're going to use a table for these, and the table, look that up in this section, 13.5. This table 17 or something along in there. Yep. 13.5, areas under the normal, under the standard normal curve is what it's titled. See the table I'm talking about? Yep. All right, looking at that table there, 13.5, here's the picture. Let's talk about it. 0 to z. What the table gives you is a percentage of values for each z value. So it goes from the middle to z. Now, that's the first point to make here. Notice that the table is based upon z-scores. So, what we're going to have to do with our values is convert them to z-scores. And what's the z-score formula? Z equals value minus mean divided by standard deviation. So we're going to have to convert all of our values over to those z-scores and then look them up on the table. Now, what the table gives me then, oh, and by the way, why is 0? I thought the mean was in the middle. Why is 0 in the middle? Well, what's the z-score of the mean? Mean minus mean divided by standard deviation. Wouldn't that be 0 divided by 0? Yeah. The mean's z-score is 0, so that's why they put 0 in the middle here, because that's the z-score of the mean. All right, so what this gives you, what the table gives you over here, so you've got all these ZA columns. Obviously not going to draw them out, and I'll, of course, provide this on the test for you. But what that table gives you is for each z-score, it gives you an A, and A, of course, is that area percentage right there. So what the A, for each z value, let's say I got a z value of, my z value was 2.37. So I'd go over there and look up 2.37, which it's, oh, it's, yeah, 237, you got 491, it's somewhere over here. Got a 0.491. So that would mean between that value, which has a z-score of 2.37, and the mean, between the mean and that value, you have 0.491, or 49.1% of the values are between it and the mean. Okay? So it's kind of what the empirical rule gives you. You know, the empirical rule gives you different percentages, but this just gives you a whole lot more options. We can do any, look up any z-score, any value, convert it to a z-score, and then we can look up any of those values up here. Okay? So that's what the table provides. So let's see how we utilize that. for these particular ones. The average length of fish caught at a lake is normal with mean of 12 inches and standard deviation 4.1 inches. Mean is 12 inches, standard deviation is 4.1. All right, so find the percentage caught between with the length between (12) and 15 inches. Find the percentage caught, percentage of fish caught with length between 12 and 15 inches. What do you think our first step is going to be here? Draw the picture. Draw the picture. And on these, what goes in the middle? 12, yeah. Yeah, we'll just stick with regular values. We could do them to the z-scores if we wanted, but let's go ahead and leave them as regular values. Let's stick with the 12. And then 15, of course, is over here. And note here that 15 is not a nice standard deviations away. That's why we're not using, because if I went one standard deviation, that would put me at 16.1. And so if it doesn't exactly fit, we can't use the empirical rule. So 15 is not a nice standard deviations away. So no, this one, because of that reason, yeah, we're going to have to use the table of values that we just talked about. And on the tables, we're wanting this, of course, between 12 and 15. And on the tables, we need to use what? Scores? Z-scores? The table uses z-scores, so I need to get the z-score of 15. Now, the z-score, I don't need to do the z-score of 12 because 12 is the mean. Most of them will have to do z-scores of every value, but in this case, I'll just need the z-score of 15. What's the z-score of 15? How do I do it? Value minus mean divided by standard deviation. What would that be? That would be 15 minus 12 divided by 4.1, which is 3, divided by 4.1, which is point something. And notice that the z-scores on the table, how many decimal places do they have? The z-score on the table has, each z-score has 2 decimal places, so I'm going to round this to 2 decimal places. 3 divided by 4.1, so that's 0.73 to 2 decimal places. So what I do is I take that and I look up the z-score of 0.73. What do you see on the table for the z-score of 0.73, the A? What did I say? 0.73. Yeah, it's on the other side there. 0.267. Okay, so the A that goes with that is 0.267, or 26.7% if we convert it to percent, 2 places, right, over. Now, make sure we understand, what does that give me? That gives me, this is the percentage between this value, which is 15, and the mean. Which is exactly, in this case, what I want. I wanted that. That is 26.7%. So I don't have to do anything with that one. It's a rare problem. just to get us started, okay? All right? That's what you do. Number 2, find the percentage between 10 and 16. Find the percentage between 10 and 16 inches. Okay, same look. 12, the mean, is right in the middle. 10 goes where? Below. 16 goes above. So I want to find from here to here. Like I was saying, usually if there's more than one value, here I've got 10 and 16, you're going to have to find the z-score of both because the table is based upon z-scores. So we need to do the z-score of 10 and the z-score of 16. Let's do 10 first. Talk about it. 10 minus, what do I do there? 10 minus the mean. Mean is 12. Divided by standard deviation 4.1. So I have negative 2 divided by 4.1, and again do that to 2 decimal places. Negative 2 divided by 4.1 is, I'd round that to negative 0.49. It's 0.487. So I'd round it up to 0.49 for 2 decimal places. But it's negative. Now looking at the table, do you see a problem with this being negative? Are there any negatives on the table? No. There are not any z-scores that are negative. However, the normal curve is symmetric. So, guess what I can look up in place of negative 0.49? I can look up positive 0.49. The A for the negative z-score is going to be the same as the positive z-score because it's symmetric. It's symmetric. So just look up positive 0.49 and that'll be your A. A is, what do you get? 188.188, which is 18.8%. Okay? Let's do it for 16. So 16, the z-score would be 16 minus the mean, which is 12, divided by the standard deviation, which is 4.1. So that's 4 divided by 4.1, which is still a point something. 0.975, so I'd round that to 0.98. So we look up 0.98 on the table. What do you get there? 0.336, which is 33.6%. Gives me 2 percentages. What do I do? Well, some cases you add them, some cases you subtract them. And we talked about it a while ago. How do I know add them or subtract them? You add them if what? You subtract them if what? You add them if they're in opposite sides, if they're on opposite sides of the mean. You subtract them if they're on the same side of the mean. Which are these? Well, 10's on the left, 16's on the right. They're on opposite sides of the mean, so we add them. Yeah. What happens is this percentage is 18.8. This one is 33.6. So yeah, you just add them. 18.8 plus 33.6, 52.4. Okay? Number 3. What percentage are between what percentage are between 5 and 10 inches? What percentage of fish caught here are between 5 and 10? Well, here's my mean, 12. 5 and 10 are over here, both on the left. So I want to know that. Okay, so again, not nice standard deviations away, so I'm going to utilize z-scores for the table. Do the z-score of 5. 5 minus 12 divided by 4.1 would be the z-score there. So it gives me negative 7 divided by 4.1, which is negative 1.71. Again, it's a negative, so I just look up the positive counterpart, 1.71. 0.456. A is 0.456 from that table, which is 45.6%. Then I do the z-score of 10. 10 minus 12 divided by 4.1 is negative 2 divided by 4.1, which is 0.49. We already did that one, didn't we? Look that up on the table, which that gives me is 0.188, isn't it? Which is 18.8%. However, 5 and 10 are on the same side of the mean. What does that tell me? Well, on the same side of the mean, subtract the percentages. So instead of adding these percentages, I'm going to subtract. 45.6 minus 18.8. What does that give me? 26.8. Yeah. I've got 45.6% between 5 and 12. I've got 18.8 between 10 and 12. So stands a reason that between 5 and 10 is the difference of those two. So that piece right there is 26.8%. Okay? Got one more for you. What is, number 4, what is the probability a fish caught at this lake is less than 4 inches long? What's the probability a fish caught at this lake is less than 4 inches long? Uh-oh, we've jumped to probability. But remember what I said from the very beginning. Area under the curve equals percentage, but it also equals probability. It's asking the same thing. This is asking the very same thing we were just doing. I mean, it's different numbers here, but I'm going to do this the very same way. I'm going to use my table. I'm going to draw my curve. 12's here, 4 is way over here. Out here, okay? But I'm still asking for that area or that percentage. That's really all it. Okay, so don't let the probability thing throw you. It's still asking the same sort of thing. All right. So what do I need to do here? Well, it's obviously not nice standard deviations away, so I need to use the table there. So I'm going to use my z-score. Get the z-score of 4. So that's 4 minus 12 divided by 4.1, which is negative 8, divided by 4.1, which is negative 1.95. standard deviation. Yeah, it's given. Yeah, these two remain the same throughout. It's the mean and the standard deviation. So take this value minus the mean divided by the standard deviation. That's given. All right, so we look up positive 1.95 because it would have the same area as negative 1.95. It's 474. A is 0.474, which is 47.4%. But is that my answer? No, it is not. This again, remember, that's the percentage of values between the mean and the value. That is this percentage between the mean and the value. That's 47.4%. 47.4%. How am I going to get this? The less than. Well, remember we talked about it. Anytime it has the less than or more than phrase, that's usually adding to or subtracting from 50. Which is it here? Subtract from 50, yeah. In this case, to get this piece, since this piece is 47.4, this piece is going to be 50 minus 47.4, which is 2.6, 2.6%. So the probability, 2.6% probability, or 0.026 if you want that way. Okay?